7 on building a titration curve is just the second lecture where we're looking at making a titration curve. This will show you a couple interesting things that you have to pay attention to during a titration, and it will introduce a new unit called millimoles. Okay, so the point is simply that we had 60 mils of NaOH in this burette. We just dumped 10 mils of NaOH into this beaker. So now the first thing to notice is the beaker used to have 50 mils in it. Now it has 60 mils. So that's going to matter. So you have to keep track of the volume in the beaker. It keeps changing. Okay, so the question once again is what is the pH in the beaker? So you start with stoichiometry, and the reason you start with stoichiometry is you just added a strong base to that weak acid. That strong base is going to force that weak acid to give up its protons, and it's going to create a reaction like this. OH minus plus weak acid creates a non-equilibrium because the strong base rips all these H's off of there, and you end up with a non-equilibrium. That's your stoichiometry. So you have to start with getting the moles that are going to react. Because volumes are so small in titrations, they introduce a new unit called a millimole. If you want to fiddle around with that math, you can do it. It just is a great unit for titrations because you're using mils and then you're using millimoles, and then you just get molarity. So it's very useful in the rice part. We'll talk about that when we get there. Okay, so it says we need moles of reactants to do stoichiometry because volumes are small in titrations. We use a new unit, millimoles. It's equal to 1 times 10 to the minus third moles. Okay, so we're going to get the millimoles of the two reactants. OH minus millimoles is, we just added 10 mils. It's a 0.1 molar solution. So you'll note we're not using liters. That's the beauty, because we're using such small volumes. This is why millimoles comes into play, because you'd have to change everything to liters and you get these little tiny numbers. So you get better numbers when you use millimoles. So you take the mils directly and multiply it by the molarity, and you get 1.0 millimoles. Then for this acetic acid millimoles, you take 50 mils, which were in the beaker originally, times 0.1 molar, you get 5 millimoles. So in the beginning, you're always going to start with 5 millimoles of acetic acid because you started with 50 mils of acetic acid. So you're not, well, let's just leave it at that. You just take the volume of the actual solutions, like you're going to take the actual volume of this in the stoichiometry part and multiply it by the volume you use. You're going to take the actual volume of this, which is always going to be 50 at the start, and you're going to multiply that by 0.1. And you're going to see that we always start with 5 millimoles of acetic acid when we start this thing. So these are our starting moles. So we plug those into stoichiometry. So we're starting with 1.0 of that and 5 of that. Then this thing goes to completion. So this, you end up with 0 of this, you end up with 4 of this, you end up with 1 of that. So these numbers right here and here are going to be some things we start with when we move on to rice. Okay, so now you have an equilibrium. You don't want millimoles in that, you want molarity. So this is really easy because because you've got mils and you've got millimoles, you just divide the one into, that's what we're doing right here. So there's 60 mils in the beaker. So we're trying to figure out our initial concentration of acetic acid. It's just going to be 4.0 millimoles divided by 60 mils. And our initial concentration of C2H3O2 minus going to be 1.0 divided by 60. So that's why this is easy to do. You just take the numbers here and divide it by the mils. They're both 60 mils because now you've mixed them and now there's an equilibrium in this beaker. Okay, so you have minus x plus x plus x. You end up with that math right there. You just assume that x is 0 relative to those numbers, and you kind of check to make sure that's valid when you solve for x. So if you assume x is 0 compared to this and this, you end up with this math right here. X ends up being equal to 7.19 times 10 to the minus fifth. That's your H plus concentration. And you get a pH of 4.14 after you added 10 mils of NaOH. So right now you have this is your 0 mark and this is your 10 mil mark. We're building that curve. So just, probably review this with regard to millimoles, and thank you.